Hello Internet and welcome to my presentation on object-oriented programming, the better version of it. And to start off, let's look at objects. Objects are fundamental to object-oriented programming. I mean, anything can go well, like that picture there, or that calendar, or me, or this, or that, or yeah, I mean, pretty much anything can be transpired to be an object in the world of object-oriented programming. And they display these characteristics in two forms, states and behavior. And basically, states are what it looks like. So like me, human, black hair, beardy, mad. And the behavior is like happy, sad, crazy, and suicidal crazy. Yes. Yes, basically those, it's like just inspired like that. And you can look around anything and you ask those two questions like, what state is that computer? What behavior is that computer? And different, it might have some variables like this lamp, my wonderful lamp. Yes, my British lamp. It has two states, on or off, or behaviors to turn on and turn off. Might have got muddled up, but the format's still the same. Or like a radio would have like turn on, turn off, increase volume, decrease volume, tune. There's more variables in different objects. Like my laptop might have millions and billions of states and behaviors. You just got to think quite hard about that. And also there's an extension of that. There's another version called software objects, and they work in particularly the same method as a normal object. Basically, a software object should be a picture of how it's modeled. It should be somewhere here. Works in the fundamentally the same method as normal objects, but its variables are displayed as fields and methods, which are basically almost the states and behaviors previously. And hopefully, and this picture should demonstrate that basically like what's the fields and what the different types of things, like the different speeds, like say on a bicycle, the methods of it, so like change gear, brake, or change cadence of it. Yeah. Okay, inheritance. With inheritance, it's like the best way to explain this is to talk about like it of any objects that have something in particular in common. So let's say for the picture up here, we're going to use bicycles for the example. And with examples, the superclass, which is the bicycle, which is the all-commanding bicycle, it's like Genesis, and you have subclasses which are the same thing but totally different, so like tandem, road, and mountain bikes. With let's say with Java programming, each class is allowed to have one superclass, like mega superclass, like king of the world, and you can have as many subclasses as you want. So you can make a motorbike, dirt bike. The list can go on and on, really. To further extend on what I've been saying about inheritance, you have to go all the way back and look at classes. And classes is basically like, it's just any objects that have all the same kind, so like bicycles, what I've mentioned, other bicycles, same make, same model. So basically, it could be like, in China, it could be like billions of similar cycles, all make, model, same size, made by the same people in the same factory for relatively wage before I offend most of the internet after saying that. So basically, it's just an object that has you can find anywhere. So like TV, PlayStation 3s, Xbox 360s, you know, kind of, because they're all very much the same. And with classes, the bicycle is an instance of a class known as bicycles, and the classes is the blueprint in which the individual objects are created. So, if I had to say, so like over here should be an example of the coding that you can use to implement the class of bicycle, which should be laid out in a Java programming format. But the only difference you can find is probably it will not contain a main method because it's not a very complete application, and the responsibility of creating like new new bicycle objects belong in different classes within the application. Right. With interfaces, yes. The main debate. Two examples I'll best describe this is auto car makers. You know, the big ones like VW, Mazda, Honda, Fiat. I mean, the list can go on and on and on and on. Usually, what they do is they have to write the software to make their car run. So like stop, start, accelerate, turn left, turn right, fuel pressure, air to fuel ratio. I mean, the list can go on and on and on in my case, but we'll leave it at that. And another note, and also GPS, like makers like TomTom and all the rest, they would use like the global, their position of their GPS of where they are around the world, and like the anything to like traffic conditions. So they would use those information to like, right, there's a lot of traffic going through. So what if I go left and start towards Dartmoor, for example? I may avoid all the traffic that's in front of me. Kind of works like that. Yeah. With interfaces, are very, very, very good job. I mean, it's only used as a reference. I mean, it can only be implemented or extended, basically, another interface added onto it. If, let's say, and also they're very common with APIs, because it's another format of it, because it's actual application programming software interfaces. It's very common with software products. So, like, let's say for instance, Apple will put their API into the iPhone. So basically, they'll give it to their customers. But in how they implement it, they'll keep it closely guarded. I mean, basically, the kind of thing. Basically, if you probably found out you'd be fired, so to speak. Fired, if I can more like. Yeah. So basically, the API is what the customer base relies on, but how they implement it, that's what Apple keeps them safe. Interfaces, the only problem is with interfaces within Java, there is a few like notable problems. For example, you cannot have multiple inheritance. You cannot have that at all. But with interfaces, there is an alternative. So you can only have one class, but it can have multiple interfaces. It can have as much as it wants. It can go mad. It can just go crazy. Therefore, objects can have multiple types of their own classes, the types of interfaces they will implement. It's just, yeah. Yeah, this isn't really the end because I've got one bit. Polymorphism. And polymorphism is kind of Very simple to explain. Because it happens right in front of your computer. Very simple. So let's say, for instance, you know the normal cursor you have, like the pointed arrow, like this one. Then when you hover over, then you suddenly think, and you hover over something like a search button, it will change into this. And it kind of, that's technically is polymorphism. Basically, the cursor changes its shape to one to another. Fairly simple. Also can be found in most commonly in games. So like, for instance, like how the colour changes. Like the colour of it changes. So like, say, take for instance Call of Duty. I mean, it's the most border simple. Like the cursor's around the middle, it would have. I mean, when you put hover it over an enemy, it will change red to tell you, "Ooh, bad thing, but shoot bad thing." Or when it changes green, you say, "Ooh, good thing." But if you're American, you think, "Ooh, good, bad. Which one do I shoot? I shoot both." Yeah, basically that is the brief explanation of polymorphism. I didn't know. Very easy to implement and maintain. Don't take a lot of data. And yeah. Now this is the end. Now if I bring Tuggy, see? Look at Tuggy, see? Say hello, goodbye. Say bye, Tuggy. Say bye. Say bye. Say bye. Bye. With polymorphism, take two. Right, with polymorphism, it's very simple. I mean, I can't speak English, for Christ's sake. I can't. Why? Whoever made this video, I will hunt you down and kill